Welcome everyone to this webinar by One Spatial on enabling seamless data integration from common data environments with FME. Before we get started, a brief introduction. My name is Adrian Porter. I'm a managing consultant here at One Spatial. I've been with the company since about 2001, and I've been working with FME for about the same length of time. One Spatial is a leading global partner for safe software and reseller of FME. Since about 1999, we've honed our technical expertise in the FME products, and our certified consultants help our customers who benefit from over 50 years worth of experience in the field of geographical information. We work closely with Safe Software to ensure we get the very best value from all of our FME products. So to start off, the takeaways from this webinar I hope you'll have are: organizations have data challenges when managing their infrastructure projects. The use of a common data environment solves many data organizational issues, but can create interoperability challenges. FME is a great tool to help solve those challenges. Inherently, this is a data integration challenge. Data integration and data quality are key elements to information management. Organizations are dealing with large volumes of data, often with expectations of near real-time integration to provide up-to-date and relevant insights. Underpinning this is the need for data quality and consistency. At the heart of information management, for a lot of organizations, the implementation of a common data environment, or CDE. So let's start with an understanding of what a CDE is in its most simplistic of terms. A CDE is a cloud-based digital space that provides an organization with a single point of truth for project information. An immutable data store where content relating to a project such as documents, emails, CAD drawings, BIM models, and GIS geodatabase, amongst others, are stored. This reduces errors, improves collaboration, and provides streamlined workflows. We can see a CDE as the touch point between the appointing parties, the supplier, and the appointing parties, the customer or asset owner. And again, in simple terms, this is the end point of the supplier's activities and the start of the asset owners. A CDE provides us with a project information, or PIM, view of the data. What the asset owner is trying to achieve is an asset information model, or AIM, view of the data. The AIM view allows the asset owners to perform business operations on the data, such as compliance and insights. Therefore, integration with the CDE is needed by tools to achieve this. I want to take a brief look at some of the CDE platforms out there and that you may be using yourselves or may already be familiar with. These include such platforms as Autodesk BIM Collaboration, Bentley ProjectWise, and A-Site. This will act as a good starting point for us when we start to look at functionality within FME itself. And so here we come to focus of the webinar. We have an interoperability challenge, especially at the point of handover. Has the expected information been supplied? Does it meet the requirements and conform to expected standards? This can end up being a manual process at times, with long delays in information becoming available in a structure that can be used by the organization. It is here where FME becomes our hero, with its platform integration and extensive format support to help us solve these interoperability challenges. So what is FME? FME is a no-code ETL platform, extract, transform, load, and we can call it a data warehousing tool that extracts data from a source, transforms it to fit the user's needs, and then load it into a destination data set or data warehouse. FME has a particular focus on geographic data, but its capabilities cover many types of data, both spatial and non-spatial. FME currently supports around 450 plus format types of GIS, CAD, BIM, database, cloud formats, just to name but a few. So FME is made up of three main elements: FME form and FME flow. FME form, formerly known as FME desktop, is the authoring tool for the FME platform. This includes the application FME Workbench, the no-code tool for building workflows, and the FME Data Inspector for viewing and reviewing data. In FME Workbench, we place objects onto the canvas that represent readers, writers, and tasks. These objects can then be chained together to form a workflow. These workflows can then be saved as an FME workspace where they can be rerun again and again and again. FME Flow, formerly known as FME Server, is the FME platform in the enterprise. We can take those same FME workspaces written in FME form and integrate them into much larger workflows. These workflows can then become event-based triggers, automations, schedules, and custom server apps, all included under a stable and secure environment. So when writing workflows in FME, the focus, as it should be, is often on the task at hand. Transforming data to what we want, running validation, checks to provide assurance, providing reports, and writing it to a new destination data stores. We often treat the read and write of a data set as the start and the end of the workflow, or maybe what we can think of as the bookends. But often the process must extend beyond these bookends, especially when our content is in a CDE, and even more so when we want to achieve seamless data integrations. As often it can be the case that the data sets that we want to read, we need to go and find that data set. We even need to search it first or filter the files before we begin to process them. And also then at the point of writing, we maybe need to restructure the data, change the file name, or move it to a different location or set of locations. So with reference back to our earlier table, we can see some examples here of these platforms as referenced in FME, just to name but a few of them. The ones I've listed here are what we might call out of the box. They are transformers, they are functionality that's ready to go, but we can also, with the use of APIs, help us extend this integration into many other forms of platforms. So let's start to have a look to see the integrations in FME form. FME Workbench has a transformer gallery. That lists all the available transformers available for us to use. These are conveniently categorized into subject matters. The integration and web categories are of particular interest to us for seeing transformers useful for working with CDEs. A transformer is an FME Workbench object that carries out a specific action on features. Transformers can be chained together along with readers and writers to create our workflow, and the workflow is saved in an FME workspace. There are hundreds of transformers out there that all perform different tasks. An FME workspace author can build their own custom transformers if they need it to meet very specific tasks to them, or they can be supplemented with community-created custom transformers via the FME Hub. FME connectors are a type of transformer, and typically they are mainly used to connect to data sets, formats, or platforms which are typically cloud-based or service-based. FME connectors can be supplied as an FME package, which deploys content needed to support the connector. These packages can be deployed and updated separately from the FME version of FME. This is different to other transformers, which tend to only get updated with an FME version change. It can also be noted that you can create your own custom connectors if needed, and these can also become accessible via the FME Hub. Okay, so now let's have a look at a few specific examples and some specific transformers that are dedicated to connecting and working with CDE platforms. So again, we can look at this by checking out the transformer gallery. And just from briefly looking, as you can see on the screen, we can see out-of-the-box connectors for ProjectWise, Autodesk Document, Google Drive, Dropbox, and OneDrive. These are all dedicated transformers we can use to connect to these platforms and interrogate the information about them. So what can these connectors do? These connectors are GUI driven, as we can see in the example for the Google Drive connector on the screen. We have a number of factors we can set to allow us to perform our connection information. So most importantly, we can obviously need to authenticate, so we securely connect to our CDE. Then in most cases, we have a number of options we can do. These include listing, so doing a search to list out files available, uploading files to the CDE from FME, download, getting data down from the CDE to read or to do another operation with, or delete. Now, these are very broad terms, and each connector has its can be extended and has its own set of unique functionality. We can see these as supporting transformers or utility tasks. We are typically getting data ready for processing. So again, going back to the idea of bookends, these are sitting outside of the bookends, getting information ready to be read, and then doing something once data has been written. Even if FME does not have a pre-made connector, it is likely that the platform will have an API. An example of this is ASITE. APIs are common, if not in some cases being the only way to connect to data and platforms. There are numerous transformers to help us to connect and interact with APIs. You can see a couple on the screen. So as the name suggests, we have the HTTP caller. And this is used to manage HTTP requests to do put, post, get, delete statements. That's via the API. And then we also have a suite of transformers specifically used for managing JSON and XML. And these can be used to format content that is used as part of upload requests, or with dealing with responses coming back from the APIs. And it's worth noting that in many cases, these pre-built connectors are basically using an API under the bonnet, but it's just been pre-packaged in a nice, convenient interface ready for you to use out of the box. So, strictly speaking, this is not a CDE, but shares some similar concepts. So I wanted to talk to you just to add in some extra value around local file shares. And there are some great tools that may be useful for you to know. One is a reader called the Data Directory and File Path Names. This is like a DIR. It allows us to return of lists of directories and file name paths, which we can read into FME as features. This listing is useful for things like data discovery exercises and for retrieving files and then pass them on to another reader to either read in their content or just analyze the files names themselves. This can often be helpful for looking for files of a certain type when there's an unknown set file location, or can be helpful for looking for things like duplicates. The other interesting feature is a writer, in this case called file copy, which again, as the name suggests, allows us to copy or move files within a local file share. Again, this is a very simple idea, but can be very useful for helping us during data discovery exercises. And the last one I just wanted to mention in this little adjacent piece of information is a transformer called the file name path extractor. And as the name suggests, if we give it a file path, it can be used to extract certain elements of the file path, such as the extension, the name, the root name, or the whole directory path. Again, can be incredibly useful in looking for data duplicates or types of data during data discovery exercises. And so this provided a bit of an overview of some of the out-of-the-box transformers that you can use to interact with CDEs. And in this last part of the webinar, I'd like to go into an example we've worked on in a bit more detail. We recently worked on a proof of concept to look at the idea of automatically verifying PDF files uploaded to a CDE. And in this case, the CDE in question was ASITE. The plan was that files would be uploaded to ASITE, FME flow would be configured to check for data in a near real-time method. We would then have an FME workflow built to run rules against these files, providing assurance against the data quality, and then providing a report. And this report would be then handed back to ASITE to be picked up by the supplier or the upload user to fix any issues. The search part of the process uses the ASITE API. And in this case, we're using an API call called the document search. This document search can also be used to filter files and list out files of interest. So in this case, we were building up an upload package, again using the JSON template in this case to build our query, and then the HTTP caller to make the request. We can then see we are then using other transformers like the JSON fragmenter and the JSON flattener to get this information out to make sensible information. In this case, we were potentially going to be dealing with many files that could all be being uploaded at the same time. So we decided to manage this in a slightly more modular way. So as part of our workflow, we then created little packages of metadata around each file for each job in a JSON package. The information could then be used as part of a next job. And in this case, we are using some functionality in FME called an automation writer to then trigger a second job in the workflow. And it's that job that does the actual assurance of the file. The assurance step is a standalone workspace. And again, we utilize the ASITE API to download the file. We then use the FME geospatial PDF reader to read in the file. Now, this can give us a variety of information, such as text, vectors, lines representing the furniture and spacing and the content of the PDF, a rasterized version of the pages and the file itself, and metadata about the file. We were then able to use this information as part to do forms of assurance, and so checking things like the number of pages recorded, the page sizes. But we were then also we then took this same content and classified the features based upon predefined configuration. At the same point then, we applied rules to these features, and again using a predefined configuration to allow us to understand the quality and whether the conformance of that file. So the assurance process we are using at the moment is currently based upon explicit rules. The process we used was to store these rule definitions in a JSON structure, because we had this idea that we could potentially need to upload different configuration files for different files as we identified them, or across different projects. So we are looking to, the idea is that as the file is loaded in, this JSON provides us with the parameters needed to run the rules. And these are then integrated with our workflow to produce the results to understand the quality. Now, looking forward, we see there's a lot of potential to enhance this, and we're particularly interested in moving forward to integrate some of this analysis with the new AI engines and machine learning tools. So whilst we still think that there's a need for rules in understanding the outputs from the AI engines, we can see there's definitely a strong case, and we know a number of people are looking at this, to use AI tools within FME to understand assurance of this information. In this case, we are taking the assurance reporting, and this is the way we've handled this is to work using ASITE's messaging system. So in this case, we use ASITE's API to create a comment message. These are then added directly against the document itself, and then it can be used to notify relevant parties or actually directly integrate with that CDE's own workflow process. And then just to give an idea of how this is all brought together, again, I mentioned at the beginning, the whole workflow is orchestrated using FME Flow and their automations tools, which allow us to provide the integration at that enterprise level with other applications. And again, just sort of starting to demonstrate how we start to create this seamless integration with the ASITE CDE. So in conclusion, there is an industry focus on data integration for infrastructure projects. Data integration, quality, interoperability are key for these information management challenges. For integration to happen, we need standardized data models, formats, which is what we need to achieve interoperability. And we believe FME is a proven tool for enabling CDE interoperability. So thank you very much. But just before I open up the forum for questions, I just wanted to let everyone know that FME training is provided by One Spatial, and the information about what courses are coming up will be mailed out to you in a mail shot from this webinar. I would also like to let you know that there is a number of webinars that One Spatial hosts throughout the year, and this is one of them. Our next one in June is about Microsoft Azure in FME, tips and tricks. And then coming up in July, we have 5 hot features of FME 24. So with that, thank you very much for your time. I hope you found it interesting. And if there are any questions now, I'll be happy to answer them. Otherwise, feel free to reach out to us in the future. Thank you very much.